All right. Thank you for that as well. And so I'm probably one of the newer people in, I guess, the DataFusion community. Coming from like a kind of Scala Spark background. So I've been kind of more in that community, I guess, since like 2015. But right now, like one of the things that I work at Databricks is essentially like our open Lakehouse. So I'm doing a lot of stuff with the community catalog, and I'm also working on, with Delta Rust as well. And I also like the other side of Delta, which is like our Spark Delta libraries as well. But what I'm talking about today is essentially how do we create like open policy exchanges, and what does it look like in terms of like, portability? And this is actually like, there's kind of some cool setups when you were talking about earlier, Andrew, when you were talking about like, how do you scan for PII and how do you essentially kind of remove all of that as well? And you also kind of called out the table provider. And so my talk is going to show how to essentially go from Cedar to Google's Common Expression Language, and then how to essentially go from that to DataFusion expressions to then create essentially push down into our Delta Rust through the table provider. That's a huge mouthful of stuff, so we'll just get into it. So before we do that, I'll talk about me. So this should only take 15 seconds. I haven't actually timed it, but I'm an author, mentor, teacher, engineer, cook, and I'm also a staff developer advocate at Databricks. I also work on open source software. I've written a bunch of books. That's pretty much all of that. And so we'll move on from there because LLMs have all that information anyways. And if you want to find out more, you can just ask them. Okay, so who here struggles with governance in general? Probably everybody. I've struggled with it in the past as well. And, as we're essentially kind of getting into, a more kind of autonomous, like agentic world, governance gets even harder. So why is this? I already kind of buried the lead by also saying it. So I guess I unburied the lead, but right now we have like multi-cloud, multi-platform, multi-catalog, also multi-auth, and that is very complicated. And so for a lot of cases, like most people who aren't essentially just, working at, Databricks also is multi-auth across like, essentially every single major cloud provider. And we also work, federating to a lot of different, we federate to Snowflake, we federate everywhere else as well. And so we're dealing with like a ton of different things, but also we want to, provide capabilities as well to make it so that it's easy for other people to do kind of similar things as well. But we don't always give that away for free. And so what I'm doing today is essentially giving certain things away for free as well, which is not Databricks specific. This is something you can use as soon as I actually open source it. And so that will happen fairly soon. But anyways, right now, if you think about like, role-based access controls or fine-grained access controls or tag-based access controls, everybody kind of has a different way of doing that. And so it's not necessarily something that's been solved as an open standard yet. Like there's a lot of like pieces in the open source world. And that's why I'm going to be talking about like Cedar and Cell as a way of kind of branching what's available as open standards and potentially also kind of opening this up as, is this a cool way of doing this, right? Is this a neat way that we can actually solve governance across like the board? And we'll see. So see if this is actually interesting. So anyways, agents flip everything on their head. So there's a lot of things now where we can't just expect people to do the right thing. We have to actually enforce that directly in the engine. And so I'm going to show exactly kind of how we get to that as well. So with that said, we have hope. Things don't have to be super hard forever. They can get better kind of, day by day. But also open source is neat. And I'm really happy that everybody else has spent the time to actually open source, these things as well. So thank you for DataFusion. If anyone who's here from Amazon, thank you also for the Cedar policy language. All these things are like things that make me happy. I come from kind of a protobuf background and like a compiled background, and it's really neat that everything is essentially kind of compiled these days. And it's all kind of like composable across the board. So what are policies as code? Are people familiar with like Cedar, like the Cedar policy language, or even just like IAM, like permissions? Awesome, right? So if we think about this, right, we essentially have something that we want to do. I'm an individual user. I might be a service principal. I might be an agent that has like control over a certain, subset of many different, things, right? An agent might be, an HR agent that's going to go pull things out, on behalf of somebody who's asking a question that should actually have that information. In a lot of cases, when we think about policies, we usually end up thinking about medical, and HIPAA compliance, things like that. Like there's certain things that you can't leak, otherwise there's huge fines. And so, if we think about this, sorry, this shouldn't, I'm just gonna go. I don't remember why it's kind of coming in like that, but who cares? So Cedar policy language, right? Open source policy language built for one job, just authorization. Although you can hack it to do more than just authorization, and that's what I'm gonna show next. But so you write permissions that are essentially saying allow or deny. These are kind of binary decisions. So that's really cool. It's simple, and it's also extensible. So if anyone's familiar with kind of annotations in other languages as well, you can extend the Cedar policy language through annotations to pretty much do anything else you want. So I added filter type, I also added target table. I also have like basically like a demo of like what tag-based authentication actually looks like for actual like fine-grained access controls. So if I have policies as code, hold on one sec, just go to this part. This is another example as like applies to tag. So if I have like a PII field or a table, and I want to be able to actually ensure that no data leaks through, I can essentially create that as a policy. But a policy on its own is essentially just text, right? This is essentially kind of an extension that feels a lot like JSON. So Cedar itself has to be compiled down so you can do something with it. So without your ability to compile it and do something with it, it's just like a promise. So I worked at governance like when I was at Nike, and a lot of times governance policies sat in like box, and it's like do something with it. That's not necessarily a great way to do things. You really want to be able to actually compile everything else down. And so if I think about a policy, I need to basically do something. I need to permit and allow you to do something or forbid you and deny. On top of that, there's like a specific scope associated with an individual policy itself. The other cool thing, we think about like Cedar, you can extend it to do anything you want. So in this case, I'm actually showing like an action for a query. So the query that we're going to do is essentially through DataFusion, and then that's also calling out to Delta. And query doesn't exist in like the nomenclature within Cedar, and so it's kind of fully extensible, which is neat. So actions are extensible as your needs. You can do anything else you want with it. You can apply individual annotations, and then you can share that with the community. So essentially kind of everything kind of goes back to standards again. So you have all these kind of base things and you need to agree on those standards. So hold on a sec. So I already talked about like composability, but these are kind of like the rules in general. So essentially you're going to permit certain things to happen. If I want to forbid certain things, like I can guarantee with a Cedar policy that if anywhere within like the policy, so if I compose like many different, if I compose a lot of policies, it doesn't matter what order the policies are actually compiled in or essentially like evaluated in, I'm going to always get the same exact answer back out again. And so for some reason, if you're saying, okay, well, I shouldn't ever see this field that's PII, I should never see this field that's a social security number or anything else like that, I should be able to guarantee that no matter how a policy changes over time, that I will never be able to have that data leak in the system. And so Cedar is very good at that as well. But with that, it's just a policy. It has to be rendered, or it has to be compiled down so you can actually do something else with it. And then this is kind of where like Cell comes into play. Who here has used like Proto-Validate in the ProtoF ecosystem or has used Cell for anything else before? Awesome, cool. We've got people here in the room. This is good, you're my people. This is awesome. So Cell itself, like if you think about kind of like, composable expressions, we have many different ways of doing that across the ecosystem, whether we're trying to share, different UDFs as like JSON or anything else like that. Cell actually ends up giving you like a better kind of primitive to work with that can be compiled down. It's also Rust native as well. And so you've got essentially a Cell compiler that works for Rust. The same thing with Cedar. It's also Rust native as well. So it works very well like in the DataFusion ecosystem. Sorry. I wish that these things weren't animating. So I always kind of feel like I'm like setting myself up and I'm like, what am I actually saying? But so the elevator pitch essentially for Cell is like, it's a non-Turing complete embeddable language that works for expressions. It evaluates the way that you would want it to. This is just from like their homepage, right? So everything's like very readable. If you've never seen Cell before, this doesn't look any different than like, any kind of like Python, type expressions. The cool thing is that those expressions are very simple to parse, and it's like microseconds to actually parse those expressions. And so we can kind of skip through that as well. So the big thing though is that like for what we're doing, if I actually want to be able to, automatically scrub, any kind of PII, or if I want to like handle row filters or want to handle column masking, Cell is very good for that. And so that's, like, if that's like the only point I get across, Cell is very cool. And so if we think about like mixing Cedar and Cell, on the left-hand side, we essentially have, just a Cedar policy. On the right-hand side, we have essentially the compiled Cedar policy that also has this nice little Cell expression in it. And so if I go back to like kind of like the HIPAA or like, any kind of like healthcare type thing, say I'm a physician and I want to be able to go and take a look at, my patients. Over here, we essentially have like a permit type for a row filter. I can take a look at a table called patients. if I'm a treating physician and these are my patients, I should be able to go and take a look at their information. No one else should ever be able to look at that. And so this kind of reads, if you just kind of go from top to bottom, it makes sense, right? We're permitting patients of an individual physician as long as they're that actual physician. Otherwise, we're going to restrict what they can actually access. And so that's neat. So what else do we do with it? So we've got DataFusion. So right now, if you think about it, we have CEDAR policies, we have the extensions for row filters, we have the extension for column masks. I can compile that down, and then I can then do something else fun with that. And so given that I am now a month into my DataFusion journey, I didn't know about like the table providers until I was working with the Delta Rust team. And I made it super simple to just basically wrap a table provider. And so what I'm going to show next is essentially what govern table is. So this is essentially a trait, right? We're extending table provider. And so I'm going to share this actual code later for anybody who actually wants to have it or work with it or compile it. I'm also trying to do a demo. I know I'm only sharing like my, just like Chrome right now. I'll show a demo of everything actually working after this. But the cool thing is like supports filters push down. So if I have, you know, a non-governed table, like Delta Lake itself doesn't care about governance. It doesn't understand what a row filter is. It doesn't understand what a column mask is. But if I want to provide that to Delta, I can essentially do that by actually wrapping Delta Lake in this govern table trait. There's a lot more stuff behind the scenes that's not going to fit into a 15-minute conversation, but how we actually compile down like the cell expressions and then create essentially a DataFusion expression. Essentially, we're mapping from type to type. And so really, if we think about it, cell expression becomes an expression with just expressions, right? We're passing this essentially from CEDAR all the way down to DataFusion. And then we can wrap it in our table of choice. So you could insert essentially Hootie Rust. You could do Iceberg Rust. It doesn't really matter. And this is just another way of doing that. This case just happens to be Delta because I'm also working on the Delta project. So it's topical for me to talk about that. So if you think about this, I'm going to go and open a govern table, right? Got a URI. This is great. I've got a manifest. So policy manifest, I'm not going to have time to go into. But when I compile down my CEDAR, I had before, hold on one sec. I'll just go back because we do have time for it. Although the animations make it bad. So on the right-hand side, this is part of what I'm calling like policy manifest. And this is just like essentially the JSON output of what policy manifest looks like. So that's just compiled down as well. And it's just basically a Rust class for that. That's just our struct. So going back over here, I went too far. All right. So I have a policy manifest, and that's essentially, that's bound to an identity. So everybody here in the room has an identity, a service principal has an identity, an agent has an identity. And so that identity is also something that's extensible. Right now, it's a very simplified struct that says essentially, who's the user? Essentially, like, are they a physician? What's their role? And it's kind of very basic information that would be part of like, it's kind of like a Fisher-Price My First governance model. This is essentially kind of a POC to show how this stuff can work. And that could be extended to be essentially like, a JOT token with a bunch of other stuff that can't be broken by someone just overriding what the identity is and say like, I'm admin. And it's like, cool, that's neat. It should be essentially something that's a lot more kind of locked down. But anyways, you have an identity, you have a policy manifest, and you have a table. And from there, all we do is essentially read the actual policy manifest. That would support essentially the row filters, and it would support also the column masks. And then all of that stuff essentially just gets pushed down directly into this govern table wrapper over our table provider, which is essentially like a reference to a Delta Lake table. And so at the very end of the day, essentially all it really looks like is this. So I have a Delta Lake table, I'm gonna open a path, and then all I'm doing is wrapping that as a governed table. And this is kind of where like the governance model breaks down a little bit, right? People don't have to wrap it as a governed table, and then essentially you're leaking PII. But if you're running this as a service and you're following actual governance models, then you don't have to worry about like people doing the wrong thing. But as long as things are being wrapped, you can guarantee that everything's gonna actually be pushed directly down, and people can't really bypass it. So if I think about like the plan that I'm looking at right over here, right? I've got a projection. I can't do anything else after I read the Delta scan before actually returning things back. Right now it's just going to standard out. So not anything too crazy, but there's no really way to bypass it. And so going back to basically like DataFusion being like the really good like intermediary for all of this, like this is not really something that's like really available elsewhere. I have like a basically kind of a hack working like for Apache Spark as well that supports like the same execution model. Um, but you can essentially just like ignore essentially any of the filtering or anything else like that. And so with this, like I feel like things are kind of a little bit more concrete, um, if that makes any sense as well. So really, all this is doing, we've got a Cedar policy that compiles down to cell expressions. So cell expressions essentially become interoperable with like DataFusion expressions. That's all wrapped in a governed table that takes a policy manifest and like an identity of a user. And at the end of the day, it will adhere to any governance models you have for like row filters or for column masks. And so I'm calling this a polycast because it's a policy and it's basically being cast to any language. It's not very smart, but it's essentially, how do you govern something using just Cedar? How do you compile that into like a portable cell expression? And then can we push that enforcement to like the query engine's actual physical plan? And this also works as well for like, for logical plan resolution within like Spark as well. And I'll show a demo. We get some time. Hold on one sec. Let me stop sharing. I'll just basically pull the screen back up as well. So we're in the demo. I think if I stop talking, the mic turns off, so I apologize for that. So this is like essentially just the demo. So it's taking like a temp table. I also have like a Unity catalog sidecar, which I'm not gonna have time to go into as well. And that's essentially where like the policies and everything else are being stored, so that it doesn't have to be like compiled down on every single individual run for the query. But in this case, I have Alice at hospital.com. She's an analyst working out of US East. And we've got bindings for essentially legal hold. We've got bindings for row filters and bindings for essentially like HIPAA compliance and for PII tags. Our query is essentially across like a patient, name, social security number, diagnosis. So if I'm an analyst, I shouldn't be able to see social security numbers or diagnostics because our policy says that only the physician can see it or an admin can see that. And so she'll never be able to see any of that information. And that's pretty much it. So that's the demo. And I'll share this soon. So thank you for listening.
All right, just plug in somewhere. Here it is in the background.